So it's a joint work with a thesis student of mine, Elif Tosun, and endogenous game choice and giving behavior in distribution games. So very briefly, the roadmap for today, I'll motivate and present the question, and I'll very briefly tell you about the literature, related literature. I'll tell you about the experimental design and implementation, hypotheses. So we both conducted a lab experiment and an online survey. So I'll give you the results of both and I'll conclude, hopefully on time. So we all know here about some of the external validity critiques aimed towards the experimental economics or experimentation. You know, just to name some: artificial lab environment, small stakes, student subjects, big experimenter is watching you, cultural differences, and all that. And Armin Falk and James Hackman in 2009 wrote a beautiful article. And this is my favorite sentence from that article. Well, they basically say that if anything, we should run not fewer but more experiments, because you know, if we take these critiques seriously, okay, let's test whether our results are robust to these critiques or not. So that means running more experiments, and our motivation is related to a sort of an external validity critique, and the related observation is, well, in most experiments, we have exogenous assignment of treatments, in contrast with many real-life situations. So we have multiple treatments, and we randomly assign subjects to treatments. So in that treatment, whatever the game, whatever the setup is, they just play it. But in many real-life situations, well, at least to some extent, people have some say, some power, some discretion over the strategic interaction that they want to be involved in. For instance, American car maker Saturn realized at some point that, well, most of their customers are women, and women do not want to haggle, so they started no haggling policy. And so we also know eBay's best offer platform. Well, the auction platform was the very popular one. They also started the best offer platform. If you want to haggle, if you want bargaining, well, you go for the best offer platform. If you don't, then you don't. And well, in many competitive situations or labor interactions, well, there could be per piece payment for the task, or there could be rank order competition. If you don't like competition, well, you choose the other option. And well, for donation campaigns, well, you may tell them, well, please don't call me, or please, you know, take my email address from your database. So basically, the rule of the gist of the idea is you have some choice over the strategic interaction that you will be involved in. So we want to continue with this idea in distribution games. So, well, distribution games or giving can be studied under various contexts, but dictator game is, well, one of the most popular ones to study giving behavior, other regarding preferences, altruism, etc. So now take these two and bring together. The question is, does it matter whether the particular distribution game at hand is exogenously assigned or chosen by one of the players? And consequently, would giving behavior be affected by this? If so, how and why? So these are the questions that we're going to deal with. I will, in the interest of time, I'll skip this, but basically this work is related to two strands of literature. One is about the interpretations of dictator game giving, which sort of evolved over the years with new experiments. And among those, you will see that List 2007 JP and Bardsley 2008 experimental economics will be the most related or most relevant ones for our work. And it will also be related to this tiny little literature, which we can call as endogenous game choice, where, well, subjects choose the game that they want to play. So let me start with the lab experiment. We ran it at Bilkent University with 268 students, a fairly balanced sample in terms of gender, average age 22, 11 sessions. Average session took about 20 to 25 minutes, and the sessions were conducted from December 19 to March 2020. And the setting is very similar to that of LIST 2007. To have compatibility, we wanted to fix so many things the same as in LIST. So it's double blind, and we conducted it on a paper and pencil basis, and the decisions in closed envelopes were carried by research assistants. It's a one-shot experiment between subject design. So every subject plays one game and only once, one type of a game and only once. And in this kind of a game where, taking away money from the other player's pocket is possible, anonymity and confidentiality are very important. So we had two different rooms for the dictators and passive players. And those rooms have different doors away from each other, and subjects left rooms at different times. And we also conducted a post-experimental questionnaire, which had the very short version of Big Five personality test and some demographic questions. Treatments, we had 3 treatments, 2 of which acted as control treatments. So in control treatment 1, we had exogenously assigned dictator game. In control treatment 2, we had exogenously assigned taking game. And in the experimental treatment, passive subjects choose the game to be played, the dictator game or the taking game. So let me give you some further details about these. In the exogenously assigned dictator game is not a choice, it's exogenously given. Both players are given 10 Turkish liras, plus the subject in the role of the dictator in room A have 10 Turkish lira more. And dictators decide how much of that 10 Turkish lira to give to the other guy. They are matched in room B. So strategy spaces from 0 to 10 in discrete intervals. In the exogenously assigned taking game is the same thing, but as in LIST and Bardsley, now the dictator can even take away money from the other player's pocket. So the strategy space is between -10 to 10, okay? And in the experimental treatment, first, well, I'm calling them passive participants, but they are passive in the distribution game. They are not completely passive because they are choosing the game to be played. So the people in room B, they decide which game to play, dictator game or taking game. And then dictators, knowing that this game, particular game, was chosen by the subject in room B, they make the decision to distribute, okay? So hypothesis 1, dictators give less in the taking game than in the dictator game. So for the exogenous treatments, this is basically to see whether we replicate LIST and Bardsley or not. And for endogenous treatments, this comparison is no. Hypothesis 2, passive players choose the dictator game more frequently than they choose the taking game in the endogenous treatment. Why? Well, I mean, why should I let you take away money from my top pocket? If I have the choice, well, I would choose the game in which you can hurt me less, okay, basically. Hypothesis 3, well, depending on hypothesis 2 or conditional on that, when passive players choose to play endogenous dictator game, the dictators give less compared to the exogenously assigned dictator game. Why? Well, suddenly now the game that we are given is not randomly assigned. It's not the experimenter's assignment. You chose that. So I can hold you responsible. You are accountable for this choice. So this gives me a situational excuse for more selfish behavior. You restrained my strategy set. Now I'm going to retaliate. This is the sort of reasoning. And hypothesis 4, if the taking game is chosen in the endogenous treatment, well, then there is nothing to blame for. There is no such situational excuse. So we do not expect the giving behavior to be influenced by the choice of the taking game. So let me quickly jump to the main results. So look at, so these are the number of observations. You see my mouse pointer, right? Yeah, okay. So exogenous dictator game, mean giving is 3.75 out of 10, median is 5. And exogenous taking, minus 1.17 giving, and median is 0, okay? Endogenous dictator, mean giving is 2.73, median is 3, endogenous taking, it's minus 223, and median is minus 5. So you see result 1 already, in line with hypothesis 1, dictators give less in the taking game than in the dictator game. See here and here. So we replicate Bardsley and List, and the result is highly significant. This difference, 3.75 to minus 1.17, this difference is highly significant. Well, just to note, our subjects were more generous than the ones in List and Bardsley. And well, this endogenous difference is also significant. Result 2, in line with hypothesis 2, passive players choose the dictator game more frequently than they choose the taking game. You see this from here, 37 and 13. So when we run Fisher's exact test or chi-square test to compare frequencies, we see that the difference in frequencies are highly significant at 1% level. Result 3, which was maybe the main result or the most important result for us, in line with hypothesis 3, the dictators give less when the dictator game was endogenously chosen compared to when it is exogenously given. So you see 2.73 and 3.76. So giving is 38% higher, 38% higher in the exogenously given dictator game. And this difference is significant at 5% level. And then we wanted to see whether the difference survives in regression analysis. And indeed, it is even stronger in the regression analysis, even after controlling for many other variables. You see, it's always negative and significant, and in the most inclusive regression, it's significant at 1% level. So it matters whether the game, dictator game, is endogenously given or exogenously assigned. And in line with our hypothesis 4, such a difference do not exist for the taking game. Although these numbers, minus 223 and minus 1.17, seem to be different, they are not statistically different. And then we wanted to see what happens in the regression analysis. Yet again, a coefficient of the treatment dummy, T dummy, is not significant. So one may say that, hey, you know what? Maybe, you know, because I look at this and I see minus 223 and minus 1.17, maybe the reason for the insignificant result is because you had only 13 people choosing the endogenous taking game. Maybe if you had more data, well, that could become significant. So we basically replicated the data, cloned the data twice, and the insignificance still remains there. So we do not believe that that is the reason. Then we ran a survey, online survey. Why? Because we wanted to get more insights about the motives behind the behavior. And we ran a survey instead of asking questions to our subjects, because we thought that, you know, there may be all sorts of anchoring and justification and legitimization, because they do something and then you ask them, why did you do what you did? Well, they can try to justify. We wanted to ask this to other people. So 296 students, 44% male, mean age 21. Survey took around 20 minutes to complete. We conducted it at the end of June, at the beginning of July. Basically, we asked them to predict the behavior observed in the experiment in relation to our hypotheses.
I mean, 5 minutes left.
Yeah, thanks. And we also asked them open-ended questions about the factors that might have driven the behavior they predicted. And we had a random payment scheme. One randomly chosen participant among the ones who correctly predicted all 4 results was paid 200 liras. And we conducted statistical analysis on predictions, and we also hired 2 research assistants who are not involved in the project to conduct some text analysis. So this is about hypothesis 1. We asked them, any difference in giving between XT and XT, do you think? Well, 82% said, yeah, there must be a difference. And we asked them, well, to those guys, to 82%, where do you predict that there will be more giving, in XT or XT? And again, they correctly predicted, 90% of them correctly predicted. And for the taking game as well, for the endogenous version, again, they 73% correctly predicted that there will be a difference. And of that 73%, 58% correctly predicted that there will be more giving in the dictator game. So as far as the hypothesis and results concerned, this is perfect. And when we look at the content analysis, when we asked him, so why do you think that there will be more giving in this and more giving in that, whatever, most frequently mentioned words were selfishness, greed, power, ability, and strategy set. So basically they said, well, there should be a difference, and well, there should be more giving in dictator, because in taking, well, I can take more, or they could have taken more. They have the power, and it maximizes their payoff, such and such. How about hypothesis 2? Well, this is the most extreme one. We asked them, do you think there will be difference in frequencies of ND and NT? Well, 90% yes, there will be. And out of that 90%, 91% said, well, dictator game will be chosen more frequently. And again, in the content analysis, they said things like, well, it makes sense. It's the rational thing to do. You know, they must have wanted more payoff, and taking game gives that more payoff. So the most important one for us, do you think there is difference in giving between XD and ND? 60% said yes. And of that 60%, 64% said there will be, they correctly predicted that there will be more giving in XD compared to ND. And their answers to open-ended questions, well, it's really nice for us because their justifications were very much in line with ours. They said things like, well, I mean, this guy, by choosing the dictator game, you know, he tried to prevent him from getting higher payoff. So this was a revenge, or this was a retaliation, or it's like punishment. Or some others said, well, it's a deliberate choice now. So this person who chose the dictator game can be held responsible or accountable for his choice, which means, well, he will be given less. So again, these predictions matched the results. And the last one, this is the only place where it failed. They predicted that there is going to be a difference between XT and NT as well. 66% said yes. And then of that, 76% said there will be more giving in NT. And this was interesting for us because they said things like, hey, by choosing the taking game, basically that person is signaling some intention. Hey, I'm prone to damage, but I know you won't do it. And as a reciprocation to his trust, you know, he will be given more, our subjects in the survey said. But that did not happen in the experiment. So I'm wrapping up. So endogenous selection into the dictator game makes a difference. When it's the passive player's choice and the other alternative is more attractive for the dictator, dictators give significantly less to the passive players. Okay. Almost all results are correctly predicted by a significant majority of our survey participants. Text content analysis showed that their explanations are mostly in line with our supporting arguments for the hypotheses. They mentioned words, as I said, responsibility, accountability, negative reciprocity, constraining one's strategy set or potential gains, stuff like that. To somewhat of a surprise to us, for the last one, they mentioned lack of trust or punishing lack of trust, or aversion to disappoint someone, which we did not observe in the experiment, but this is interesting to see. So this takes us, our results take us to the same old question: how should we interpret dictator game giving? I believe we give a message similar to the list. Well, institutions matter. How we end up there in a dictator game-like situation matters a lot. And so, as much as involvement in dictator game-like interactions we want to model in our experiments are endogenous, we need to take this into consideration. Otherwise, maybe our results do not reflect what would happen in those situations. Thank you, and I hope I'm not over time too much, maybe half a minute.
Thank you very much for this interesting talk. I mean, we have 3 minutes for questions. So if you have any questions, just unmute yourself.
So, yeah, Max, did you have a question? I saw your hand, but...
No, I just did the clapping. But,
okay, okay.
Can I ask a question about the gender effect in table 2, or are you?
It's good. You know, given the nick of time, I didn't put it into the main presentation, but we have something about it. Let me switch to that. So very shortly, men give less than women in the dictator game. And there is also a treatment interaction with the gender effect. Treatment effect is weaker on men than on women. You see that in exogenous dictator game, males give 3.15, females give 4.93. But when you move from exogenous to endogenous, you see that men do not, you know, it doesn't make a big difference. But for females, there is a huge difference. So there is a difference in the dictator game. There is no difference in the taking game, and there is a difference also in the magnitude of the interaction effect. Also, we look at as an alternative measure of giving. We created a dummy variable called zero giving, and I can say that men are more likely to give zero than women in the dictator game. And treatment effect, again, is weaker on men than on women.
Yeah, that's interesting. I mean, I was at the gender session yesterday. They were doing a taking game too, and I think they found there that women were more generous, so less likely to take in the taking game. But that's something that you then don't find. I'm gathering.
Yeah, here in the taking game, we do not observe that, but in other respects, we have a similar effect.
Okay. Thanks.
Yeah. By the way, as also a partial answer, we also wondered what kind of people those 13 people who chose the dictator game are. So we basically ran a probit regression trying to explain that choice of the taking game. And well, pretty much nothing turned out to be significant, and there is no gender effect there either.
Okay, thanks again, Emin. Time's up. So our next speaker is Pablo Branas Garza. The floor is yours.
Okay, thank you. I think you need to let me to share screen.
I think you should have the permission to share your screen already.
Yeah. You see everything now?
Yes, perfect, yeah.
Okay, thank you. Thank you very much. Okay, I'm going to talk about this paper where we link decisions in standard dictator games from standard student population, and then we link their behavior in the game, say now, to the level of inequality they observe at the age when they were a child. Okay. Well, this is a paper that is basically okay, let me explain this in a different way. So we were not looking for this paper. We ran this huge experiment, and I will explain later, with representative sample of students. And then once we have the data, we thought about to try to check these kind of things. Okay, so basically this paper is motivated by two papers. One is this paper by Fair and Berham and Rockenbach that was published in Nature in 2008, where they show these amazing results. So they have kids with 3, 4 years, 5, 6, or 7, 8 years old, playing pro-social games, NGB games, and sharing games. In the pro-social game, participants, the kids, it's a binary game where they decide whether they prefer 1-1, so that means I keep 1 for me and I give you 1, versus 1-0. That means I got 1, you get 0. In the MB game, they have to choose again between the egalitarian division and another division where the other children got 2 instead of 1. And in the sharing game, they have to choose between again between sharing egalitarian decision or keeping all for them. So we observe in this paper that while pro-social game start at like 60% and goes up at the age of 7, 8, MB is also increasing and sharing is also increasing. So this paper shows that children are not really concerned about equity when they are very young, but at the age of 8, they become like very concerned. There is a second paper, which is from Fair, Gatzle, and Suter, published in ER in 2013, where they repeat exactly the same experiment with older guys. So now you see that the kids are 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then what we observe is that prosociality, so in this case is egalitarianism, is also increasing, while MB is decreasing and sharing is massively decreasing. Okay, compared to the previous figure, although obviously these experiments are not identical, even it's not the same country, but we have, we observe something like preferences for strict equality are particularly relevant at the age of age. After that, children began to develop more complex patterns, such as meritocratic values, in-group bias, or altruistic preferences. Okay, so the question is, if children at the age of age are particularly sensitive to inequity, what we want to test is whether the inequity they observe they suffer when they are children have any impact on their level of altruism in their life. So if exposure to inequity at childhood has any impact on choices at adulthood. How we do this? We are going to link decisions, incentivized decision of 450 participants in a representative sample of a student. I will explain a little bit more later, with existing data on inequality at regional level. So that means that we run the experiments, we have a standard setting of university students, and then we compare their decision with existing data. So we don't, we don't perform anything on the data. We didn't build any data set. We just take data that are all over the place, and then we compare what happened. What about causality? Okay, obviously we don't have causality in the sense that we did not manipulate exposure. So obviously we weren't able to go back to these kids 10 years ago and make them to suffer higher, slower levels of inequality. But obviously we can also say that there is no reverse causality, in the sense that kids or students that actually they are 18 or 19 years old cannot have any impact on what happened on inequity at regional level 10 years ago, 10 years before. Okay. Just a second. Okay, so let me explain all the technical things in detail. Okay, we use a national representative sample by regions of 500 students. The universe, the population is 11,000, and we got this data from the Ministry of Education, and 50% of them are females. We are just focused on first year students enrolled in business economics. And business economics in Spanish is a particular definition that not necessarily match with business economics in the UK, for instance, say that it's something like administration or something like this. So what we are going to have is data from a representative sample of Spanish business economics student year 1, freshmen. We compute participation or the weight of every university in the sample using the enrollment in 2017 in Spanish universities provided by the Ministry of Education. According to these numbers, to the population, we compute the number of participants corresponding to each university, say 52 universities, something like that. Institutions with very few students were not included. I'm talking that I think that we missed like 6 universities. Instead, we share the shares of these remaining guys were assigned to largest universities, always in the same region, in order to keep representativity at regional level. In order to recruit a student, we contacted with university professor by email to ask them to collaborate. We only contacted with professors in charge of GR1, only GR1, according to the official webpage. So an important thing is that business economics student, all freshmen. We asked to the professor if they would like to, if they were the person in charge of the course. If they say yes, then we asked them to help us. People was very nice and everybody helped. And then we told them that before, the day before, 2 days before the experiment, we will send them an email and they have to make an announcement in class, etc. And we gave them all the specific information about login, password, etc. Okay, self-selected participant logged in the system in this webpage, which is called Behave For, which is a webpage specifically designed to run experiments. And then the participants were given 1 hour to complete the task. And they were informed that after 30 minutes of doing nothing, the system will be automatically switched off. So obviously we have self-selected students and we have no control. In the sense it's an experiment, they are at home, everything is online. We really don't know if they are taking the job seriously or not. Once the number of participants required for each institution was achieved with a margin of 5%, so no more students were accepted. Obviously, as I said before, we have very little control about what they are doing. This is the participation age, the participants' age. As you can see, there is a bunch of students with that exactly 18 years old. Also, there are a fraction that are a bit older, and there are still there are a certain number of people, say 10%, that are older than 22. 1 out of every 10 participants was randomly selected for real payment, and the 56 participants who were selected earned €41. And they played more games. I'm not going to talk about this, but everything was random. A student finally, on average, spent like 50 minutes on this. The task that we are talking today is about giving. So how much money they want to pass to a recipient. The recipient is another participant. It's not an NGO, something like that. It's a standard dictator game. And then they are asked to select in fraction of 10 whether they want to pass something. There is a typo. The last number should be 100, not a 10. If they want to pass 0, 10, 20, until 100. So this is the measure for us of decisions. And these are the results. So then we see a large majority of the students decide to pass 50%. Only 80% gave nothing. Also, there is 1% of a student giving all. Okay, if we compare this with Engel, this is not that different, but still these guys are quite generous. Okay, now I'm going to talk about this inequality measurements. So this measure refers to inequality at regional level. And then what we do is we compute inequality at individual level, in the sense that given that this individual was born in this region, what we do is to put for this individual the level of inequality at when this guy was 6, 7, 8, 9, and 10 years old. Okay, obviously this index, and I will talk a little bit about this, varies from year to year, etc. There are we use two measures. The main variable for us is this index provided by Eurostat, which is called S80S20, which is an index of inequality. And then to run a robustness test, we use Gini index, which is taken from a paper that they compute this for Spain. In both cases, we are completely unrelated to this data set. So we just use a existing data set. The S80S20 is a ratio to measure inequality of income distribution, and is computed at the ratio of total income received by 20% of the population with the highest income, okay, compared to the 20% with the lowest income. It's important to remark that these data are available for very precise years, only from 2004, 5 until 12. That means that for some older individual in the sample, we are not going to have this data, so they will be dropped. Gini index comes from the Lorenz curve, which is related to the cumulative percentage of population and the cumulative percentage of income, okay? You know, when this with maximum equality, the Gini index is 0, and when inequality increases, approach to 1. Again, we are using for every individual the value year by year of Gini index at the region of the individual. Okay, results. Let me explain first. We control for female, for gender, never significant, but we control for this. And also we control for household income. I think this is important in the sense that we want to control whether you were poor or rich, okay? In a poor or in a rich region. Okay, so the main results are here. We observe that those who observe more inequality at the age of 6 give more, 10%, even more for 7 years old, 10%. And for 8 years old, which is exactly the year that Ernst Fair and co-authors indicate as, you know, the year where the children are still sensitive to equity, then we observe the maximum value with huge significance level. Then after that, again, you see the significance is lost.
Pablo, 5 minutes left.
Okay. So this is exactly the same, but just showing the pictures. So you see again here that the coefficient is much higher here and it's highly significant and not for the other things. Then we check with what happens if we use Gini index. Then we see that more or less the results are very similar, less significant, but again, the only relevant thing is 8 years old. And the effect is identical. More inequity means more giving. And then we have some extra regressions where we divide the sample. In models type A, we have only 18, 19 years old in order to have very comparable sample. In the other model, we have older guys, so we have much less people. And again, you see 6-year-old is barely significant. Nothing happens with 7. And then again, the huge value is here. So 8 years old, again, is the most significant value. Finally, what we have here is we show 4 years old only, okay, how inequity predicts giving. And then you can see that when inequality moves to the right, that is increased, people give more. When inequality goes to the left, that means less inequality, people give less. So in conclusion, our results indicate that exposure to inequity at childhood has a permanent effect on adult life. I didn't put here, but the effect is that more inequality at the childhood implies more solidarity at the adulthood. I'm done. Thank you.
Thank you very much. If you have any questions, just unmute yourself.
Hi, Pablo. Great talk. I have a short question. So, first of all, did you look at the effect of the economic crisis in Spain on their giving decisions? Like, I could imagine that there is some correlation between inequality levels in their childhood and the severity of the crisis in 2007. And I also wanted to mention that it's your paper is quite interesting with respect to the paper by Johannes Wohlfahrt and Chris Roth that show that exposure to inequality in the formidable years, so when they're like 20, 21 to 25, actually has the reverse effect than what you find. So people that were exposed to larger levels of inequality are less averse against inequality. Yeah, so those were my comments.
Okay, so obviously we ran this experiment in 2018-19, and we did in Christmas, so we did in December and January. We know income at individual level, so we have certain control about the conditions of the household. So this may be, say, useful in order to control whether they suffer or not the crisis more. But what we are comparing is the level of inequity of the region of the individual. So if this region was suffering more crisis, which is maybe obviously will be the case, this is precisely what we are seeing, whether this region is moving in the ranking of inequity. So I think that we cannot explain everything, but in certain sense, we have control on this. I didn't show interaction and other things in order to have a more smooth presentation, but I think it's important to have the information about the household in order to know the position of the particular individual in the region. It's not because you can be rich in a poor region or in the way around. But basically, the result is, are robust. And it's a kind of magic thing, This is exactly what this paper from Fair and co-authors are showing, 8 is the right year. And we found this. So we were looking for exactly this because of these papers, with data that are not favoring anything, in the sense that we are taking data from Eurostat. So we have this giving, we have data from Eurostat, and we were going just to see whether these theories work or not. You know, data match exactly the theory, these development theories. About the paper you are talking, I'm not sure about the paper. That paper, if you can give me a copy, I will be very grateful.
Hi, Pablo. Interesting
Okay.
talk. So I was thinking, so I might have lived in an area where there was lots of income inequality, and my household income might have been high, but maybe I always lived in rich neighborhoods and I always went to rich kids' school, so I was not exposed to the inequality in my area. So my question is, do you think there would be a way, or there's some variables somewhere with which you can capture segmentation at the area level? Like this area, yes, indeed, high-income families always live in particular neighborhoods. Their kids always go to these schools, so they don't mingle with other parts of the society, whereas in this other particular area, the society is more mixed. Would you have that kind of...
No, I completely agree. I think that we don't know that information, because we don't know this information at individual level, in the sense that we really don't know the postal code of the individual or something like that. Okay, household income minima is part of this, but still you are completely right. Okay. But also something that we were completely shocked is that the lack of data. So it's not obvious that we can get this data. Yeah. So the data with this Eurostat data, which is the more official thing you can use, this is why we took this, is only available for these years. There is a second wave, which is like overlapping the first, but it's a different methodology. So we took the only one that we can use. So, and this is at regional level. Even we don't have data at city level. Oh, so this is, if you take official data, this is what you have. So I'm pretty sure that even if your region is, say, poor, that means that in this index is going to be bad. It may be the case that it's very polarized and there are a poor and a rich area. So, and this is out of control. Yeah.
Okay.
Thank you.
Yeah, sure.
More questions? So I will put in the chat the paper if you want to see the paper. Okay, we'll put the link, and then you can get the paper if you want to read it later. Okay, and thank you very much.
Thanks again, Pablo. So our next speaker is Royal van Veldhuizen, if I pronounce this right, and he will talk about decomposing trust.
Yes, and no, you didn't pronounce it right, but I forgive you because it's not so easy. So before I start, I just want to do something to make the screen slightly more visible, because otherwise you might see all kinds of weird bars on the screen. So I guess now you should be able to see most of my screen. So the only downside is that I cannot see the chat. So if you have questions, please just interrupt me and let me know. So this is a paper about trust, and specifically what we try to do in this paper is we try to figure out what explains why some people decide to trust in the trust game and some people decide not to trust in the trust game. So my co-authors on this paper are Dirk Engelman, Jana Friedrichsen, and Pauline Voorjohan from Berlin, and Joachim Winter from Munich. Now, this paper relates to a large literature in the social sciences that suggests that trust is a very important thing explaining many behaviors, right? And in economics specifically, trust has been linked, for example, to economic development and economic growth. Now, as we probably also all know, in economics, and especially in experimental economics, a very common way to measure trust is by means of the so-called trust game, right? So this trust game can take many forms, but in a simple binary case, there would be two players, one sender and one receiver, and the sender can decide trust the receiver, and then if the receiver is nice and reciprocates, the sender ends up with more than before. And if the receiver decides not to be nice and not reciprocate the sender ends up with less than if he decided not to trust, right? So this is just an example of a trust game, but there are of course many other ways to implement a trust game in the lab. Now, what we are interested in this paper is trying to better understand what it is exactly that determines trust or determines the trust action in the trust game, right? And you may think that, you know, there is a large literature now. This game has been studied in many studies for probably more than 25 years right now, maybe even longer. But in spite of that, at least our reading of the literature is that not exactly a consensus about what the trust game measures, right? So for example, if you read Ernst Fehr's paper from 2009, he really emphasizes that the trust game is about distributional preferences. Right? So the reason that people sometimes choose not to trust is because they don't want to fall behind somebody else, right? They're inequity averse. And then, for example, Carlin, but also many others have sort of emphasized the role of risk. You know, if you decide not to trust, it might be because you are afraid of taking the risk that involves with trusting, right? Because if you trust, maybe you end up with nothing, or at least with less than before. And then there are other studies that really emphasize the belief component, right? So the trust game in this view is really about, do you think that you're going to be reciprocated, right? Do you think that others are trustworthy? And then there's another separate strand of the literature that argues that perhaps another role here is played, that people just don't like being betrayed by the receiver. Independent of the payoffs, they just don't like the act of being betrayed. Now, which of these components plays a key role we think is important because it sort of changes perhaps our understanding of the trust game, which may matter for policy reasons, theoretical models, making predictions, and so forth. So what we try to do here is we want to run a lab experiment that allows us to decompose trust, and more specifically the trust action in a trust game, into these 4 components. And clearly we are not the first to be interested in the trust game or in explaining what explains behavior in the trust game, but we think we do contribute in several ways. One is in terms of scope, because we have one experiment that looks at all these 4 components at the same time, as well as potentially interactive effects between these components. The second is the method we use relies entirely on treatment comparisons. And this is also a bit different from what has been done in most studies before. And this is partly what I probably have, hopefully at least, have a little bit of time for at the end, is sort of to compare our results in this experiment to what we might find using sort of more standard techniques that I'll also explain shortly. So what I'm going to do in the remainder of the talk is I'm going to talk about the experiment we did, what we found, and how we interpret all of it. Now, this is a game. This is an experiment about the trust game. So the first thing that we did in this experiment is we actually had people play the trust game. Right now, the particular version of the trust game we use happens to be the exact same version I showed you earlier, where if the sender decides not to trust, both parties end up with 10 euros. If the sender decides to trust, then what happens depends on what the receiver does. If the receiver is nice, both people end up with 15. If the receiver is nasty, the sender ends up with 5 and the receiver gets 20. The other thing to note here is that we let people play as both the sender and the receiver. I think the main reason for this is just statistical power, because it effectively doubles our sample size. Then, after we've done the main trust game, the second thing we do is a belief elicitation task, where basically we just ask participants, hey, how many others in the current session do you think are trustworthy? So in other words, how many others who are currently in the session with you right now do you think chose to reciprocate in the role of receiver in this session? And we elicited this, basically this is a simple question that we both asked directly in this way, and also asked in a slightly more complicated way that involves incentivizing them using the crossover mechanism. So this gives us both a binary trust game decision and people's belief about the reciprocity of others in the role of the receiver in this trust game. Now, the next thing we do is we tell participants about something that we call a game earn. Now, we are experimental economists here, and if there's one thing that we like, that it's balls and urns, and more specifically, balls that are in urns, right? So the way we do it in this experiment is we tell participants that for each of them, we're going to create an urn that contains one ball for every other person in the experiment. And specifically, there will be, and the color of the ball specifically will depend on what this other person decided to do when in the role of the receiver in the previous trust game session, right? So if the person decided to be nice and reciprocate, there will be a green ball representing that person in the urn. And if the person decided to be nasty, there would be a red ball representing that person in the urn. So this means that basically we create an ambiguous urn here where people know how many balls there are in the urn, because that's basically equal to the number of participants in the session -1, because they are themselves not in the urn, but they don't know the composition of the urn. So there could be many green balls, could be many red balls, they don't know. And what we then ask them to do basically is to tell us what they would do depending on how many balls of each color there were in the urn. Or in other words, basically we want to ask them, how would you trust if 12 out of 15 recipients in the session are nice in the role of receiver? Would you trust if none of them are nice? Would you trust if 3 of them were nice? Right? And we can use this game urn to implement them, because we basically tell them like, okay, what if the urn happens to have 5 green balls in it, which is equivalent to saying that 4 recipients are trustworthy? Would you then be willing to trust, yes or no? So what this basically does is it allows us to elicit trust game behavior, more specifically trust, or the sender's behavior in the trust game, using a strategy method, where basically we ask them for any possible belief, if you want, they may have about trustworthiness, what they would do in the role of the truster, which gives us rich data, which actually turns out to be very useful and important in our main identification strategy. Now, what is our main identification strategy? Well, in a way, it's pretty simple. We basically just want to do a treatment comparison, right? So what we want to do is we want to compare one environment, let's say the control treatment, or in our case, the trust game urn, where we think that behavior can be explained by 4 possible mechanisms, let's say risk preferences, social preferences, beliefs about trustworthiness, and betrayal aversion. And then we want to compare the decision people make in this particular environment to the decision they make in another environment, where we turn off the role of one of these components by experimental design, right? So we want to run a treatment where, for example, it's still a trust game, but now somehow we turn off the role of risk preferences, right? So that risk preference can no longer explain behavior in this particular environment. Now, how do we do that? Well, in our experiment, we do this by basically running a trust game, or more specifically, a version of the trust game based on these urns, where people are paid based on the expected value of the urn, right? So basically, they are paid based on the expected value of how likely people are overall to reciprocate overall in the session, right? So for example, if 5 out of 15 people in a session reciprocate, then normally in a normal trust game, you have a 1/3 chance of being reciprocated and a 2/3 chance of not being reciprocated. But in this particular treatment, instead we pay you based on the expected value. So it means that you earn something in between the payoff you would normally get from not being reciprocated, which is 5, and the payoff you get from being reciprocated normally, which is 15. So you end up somewhere in between, depending on exactly how many people reciprocate in the session. So this removes the role of risk preference, because there's nothing risky about it anymore. It's a deterministic decision. So if people are on average risk averse, then removing the effect of a role of risk attitude should make them on average more likely to trust. So this is basically what we do. And we have then several more of these urn choices that then address some of the other components I mentioned earlier. Now, unfortunately, I don't have time to talk about these in detail, but I will briefly discuss the results of these tasks. Other things I should say is that we randomized the order of tasks, except the trust game, we always did that first, but the rest of the task we randomized. And we used neutral framing, ran it in Berlin, pre-registered the experiment, and we only use slightly more than half of the sample in the analysis, and that is because we don't want to include people who have switched multiple times on price lists and stuff like that. And we actually said we would do this way in the pre-analysis plan. So this brings me to the main results. So what I want to show you first is what happens in these trust game in the urn version. And specifically what I want to show you is what do people decide to trust, how do people decide to trust as a function of basically how likely it is that there will be reciprocated. So this is the result, basically. So on the x-axis over here, we have the number of green balls that are in the urn. And on the y-axis, we have the fraction of people that decide to essentially trust. We call it choosing in the experiment. as a function of the number of green balls. And remember, number of green balls is basically just the same thing as the average, sorry, the number of people in the session that are willing to reciprocate a trust action. And the results are kind of intuitive, right? If you think that nobody will ever reciprocate you if you decide to trust, then we find that nobody in that case chooses to trust, which totally makes sense. On the other hand, if everyone in the session were to reciprocate, then we see that everyone is willing to trust as well. By the way, the reason that, you know, I just normalize the number of green balls to be equal to 19 at the maximum, because most of our sessions have 20 people in them. And then they have up to 19 green balls. So this makes sense, right? And this basically tells us the result that beliefs about reciprocity or about trustworthiness are really important, right? Because if you think nobody will reciprocate you, you don't trust. If you think everyone will reciprocate, you do trust. And if your belief is somewhere in between, then your action is on average also somewhere in between. But next, I want to show you what happens with risk preference. So remember that here we had this other version of the trust game where basically people were paid based on expected value, as opposed to, you know, either being reciprocated or not. And what we find in this task is that trust basically goes up, right? So people are more likely to choose to trust, or if you want the trust equivalent action, once the role of risk has been removed, right? So the red line here is above the green line on average, right? And this again makes sense, right? Because if you are over here in the normal trust game, you're like, okay, about half the people are going to reciprocate me, which means that the expected value of trusting is, in our experiment, about the same as the expected value of not trusting. But, you know, I'm still risk averse, right? So even if the expected values are about the same, I'm still not going to trust because I don't like taking risk. On the other hand, over here, the risk effect is removed, and then people suddenly like, okay, I can just get slightly more if I trust, so I'm going to do it. I'm going to choose the trust action. So there's this big shift here between, you know, it's basically between 9 green balls and 10 green balls, which is exactly the point where the trust action becomes payoff maximizing, right? So a large number of people care a lot about their own payoffs, and as soon as it's no longer risky, basically as soon as the payoff becomes higher for the trust action, they switch to it. But the main takeaway here is that risk preferences matter, because if you remove their effects, then people become more likely to trust across most of the distribution. So the average effect, just integrating the area between the two graphs, gives us a 10 percentage point difference. So removing risk preference increases trust by 10 percentage points. But you can also see that this effect really depends on people's beliefs, right? So if you think that that like 11 people in your session out of 19 are going to be trustworthy, then removing risk has a huge effect, right? Almost 40 percentage points, or perhaps even more. Whereas if you think that nobody in your session is going to reciprocate, then it doesn't matter if you remove the risk, because you wouldn't trust anyway, right? Even, basically, unless you're super risk seeking. So basically it doesn't matter if you have risk or not in this setting. So like I said, we did this urn where we removed the role of risk preference. We also have urns where we removed the role of betrayal aversion and social preferences. I just want to briefly show you that if you remove betrayal aversion, not so much seems to happen, except maybe at the top of the distribution. It's the difference between the green line and the blue line over here. If you remove social preference, a bit more starts to happen. It's also in the top of the distribution, but actually already starts as soon as we get to 10 green balls. So overall, on average, social preferences have a significant effect on trust. If you remove social preferences, people become more likely to trust, which is consistent with some sort of behindness aversion.
Roel, 5 minutes left. Yes,
thank you. Now, so those are the main results in terms of basically the main, almost like, so these are sort of the main results, but what I also want to show you is what happens conditional on beliefs, right? Because if you think about the trust game, right? The trust game, previously I showed you the entire distribution, right? So what happens across all possible beliefs you may have about trustworthiness. But in reality, of course, you don't have all possible beliefs at the same time, you just have one belief, right? So what we also want to do is we want to sort of see, what do people actually do based on the belief they actually have? And how does, let's say, removing risk preference affect average trust based on the beliefs that people actually have in this experiment? Right? So for example, again, if I'm someone who thinks that people are pretty trustworthy, so I think that there are 12 people that are trustworthy over here, then maybe risk preferences will have a much larger effect for me than for somebody else who's more pessimistic and is over here. Right? So we can do this because we elicited beliefs, and we can just pick the decisions corresponding to the beliefs we elicited, and then compare across the different earned tasks. And when we do that, we magically find that risk preferences basically have the same effect as they have on average. Removing risk increases trust by 11 percentage points in this case. Now the reason for that is that for most people are actually pretty pessimistic here. So if you look at the graph, they have beliefs that are somewhere over here. So for them, removing the effect of removing risk preferences, removing all risk from the game, does not have any effect on their behavior. But then there's also about 25% of the people who are in this range, and this is exactly where you have the large effect, right? So these people have an effect of about 40 percentage points on average, and because they're 25% of them of the population are here, the average effect will then be 25% of 40 percentage point is about 10 percentage points. But social preference and betrayal aversion in this case have no effect anymore. Now, the final thing I want to at least briefly touch on is sort of say a little bit about our identification strategy, right? So what we've been doing in this paper is using treatment comparisons. We have one treatment where risk plays a role, one treatment where risk doesn't play a role, and we compare the two, and that tells us something about the role of risk preferences. Now, we're not the first to do this, but I think a far more common approach to identifying the drivers of trust in the trust game is to have a separate elicitation task where you, for example, elicit risk preferences or social preferences, right? Think of the Lori task for risk preferences, for example, and then use these variables that you just elicited as explanatory variables in a regression. Now, the potential issue with this second approach is that there are some rather heroic assumptions that you're making, one of them being linearity, right? Typically, you put all the regressions in linearly, but of course, under EU, this would not be entirely accurate because it's, you know, the expected utility is belief times payoffs to the power of risk preferences rather than something like beliefs plus risk preferences. And the other issue is that, you know, if we measure something using a Lori task as an example, we're probably not going to measure risk preferences perfectly. And this in turn implies that we might underestimate the effect of these variables. And then there's another issue here that I will briefly mention when going through the results, because basically what we find is if we compare our treatment-based estimates to this sort of quote unquote regression-based estimates, we find that for beliefs and risk preferences, the regression estimates severely underestimate the importance of these variables, right? So the belief estimate, which we have at 100%, can be as low as 30% depending on the measure we use. And for risk preferences, it can even be 0, even though the true effect that we obtain is 11%. Thank you. Now with social preferences, we have the opposite problem, interestingly enough, because there we don't find an effect ourselves on the sort of belief-based decision I was talking about just before. But if we look at regression estimate, you just throw in a variable for social preference, it will be significant and have an effect there, actually going in the opposite direction. Now, why is that? This is one of the things that Dirk has worked on before. This is probably because of the consensus effect that people who are themselves very nice and have therefore social preferences who are altruistic, they typically also tend to believe that other people are going to be nice, right? So there's sort of a correlation between these two variables. And if you control for only social preferences, then actually the regression estimate will not just pick up the effect of social preference, but also the effect of beliefs about reciprocity. And in fact, if we add also control for beliefs, then the regression estimates for social preferences go down considerably. Which brings me to the end of the talk. So what I just briefly to wrap up, we did sort of a comprehensive analysis of trust decisions using treatment comparisons where we found that beliefs about reciprocity were very important. Risk preference and social preferences also played a role, and we did not find an effect for betrayal aversion overall. I think what we also show is that there are strong interactive effects for beliefs, that the effect of risk preference, for example, depends strongly on how likely you think you are to be reciprocated. And we also showed that our results are different on the previous slide than if you just use the standard regression-based method. Now, apart from just saying that I think our results are interesting for people who want to know more and understand more about what the trust game actually measures, I think what I also want to say is that as experimentalists, it can also be very useful in general to try to use treatments to get at the mechanism more directly, right? So if we really want to see what the role of risk preference, let's say, is in explaining behavior in our experiment, then it may be possible to run a control treatment that removes the effect of risk preferences instead of relying on controlling for variables in regressions. Because at least, I didn't have time to talk about it in detail, but we believe that this leads to better results. So that's it. Now I'll make the screen uglier for you.
Thank you very much for the interesting talk. We have about 3 minutes left for questions.
Roel, I have a quick question for you.
Mm-hmm.
It was a very interesting talk, by the way. Thank you. When you use a strategy method, you put people into kind of planning mode of thinking. So the whole thing becomes a thought experiment. So when you actually interact with people and you build these experiential trust relationships, those are different, and we've shown those to be different in the laboratory. So I'm wondering how the thought experiment will relate to people who are actually building experiential trust with others.
Thank you for that comment. The short answer is that I don't know how what we observe in our specific earn-based trust game will relate to experiential trust, as you call it in general. What I do know is that the results that we obtain using this sort of strategy-based method that we have using these earns are actually identical to the binary trust game once we condition on beliefs. And what I mean by this is that if somebody trusts in a binary trust game and they have a belief of, let's say, think that they are going to be reciprocated with 60% chance, and if I go to this earn-based task and I look at what they did in the earn-based trust game, at the point where they're 60% of the balls in the earn are green, they will also trust. Mm-hmm. So at least those two approaches are consistent. So it's not like the strategy method per se changes behavior overall in our experiments.
Okay, thank you.
I also have a question. I think the binary trust game, it also includes ambiguity. Like you have no idea about how other players will play. The game you decompose is a game under risk. Like the earn is ambiguous, but you can condition on the number of balls that are in it. So in that sense, it's a game under risk. Do you think ambiguity doesn't play a role? Like it seems your results suggest this.
So the honest answer is that whatever I've been calling beliefs, you could also see as a combination of beliefs and whatever ambiguity aversion does to change beliefs into decision weights, right? So the other way to answer this to answer this question would be to say that definitely ambiguity aversion could play a role, and we thought about finding a way to remove ambiguity aversion, well, not removing other factors, but we couldn't come up with a nice way to do it. So instead, basically the role that we now ascribe to beliefs might also partially capture the effect of ambiguity aversion.
Okay, thank you very much again for the talk. Time is up, unfortunately.
Okay.
Okay, so then I will share my screen. So hello everybody, my name is Dominic and I will talk about the avoidance of the dictator game and whether this behavior is caused by guilt aversion or self-image concerns. So there's evidence for both motives, but we want to find out which motive is more important for this behavior. This is joint work with Jörg Rieskamp and Markus Schöbel, also from the University of Basel. So I started with a few examples of this behavior in the field. So these are all field experiments. And in the first study, what they did here, they placed fundraisers at the mall in the US. You see the picture here at either door 1 or door 2. And what they found is that nearly 1/3 of the people entering the mall avoided the occupied entrance. So they were willing to walk longer just to avoid the occupied entrance. People also avoid fundraisers at home when given a heads up. So when there was a note at the door saying that the fundraiser will ring the door at this time, fewer people were at home compared to the treatment where there was no such heads up given. And this is my favorite one. People even recycle less when the return deposit from the recycling machine can be donated. So what they did here is they introduced new recycling machines that allowed the deposit to be donated, and this led to a decrease in recycling. So why is this interesting? Because avoidance is quote unquote more than just egoistic behavior. What do I mean by this? So an egoist in this example here, he would just walk by the fundraisers, he would not care at all about them being there. But these people are actually willing to incur costs just to avoid this situation. So for example, here they're willing to walk longer to the next entrance. And evidence suggests that people are also sensitive to this cost. So in a follow-up experiment, they found again in this mall that when the weather was very cold, this behavior was no longer observed because then the cost of walking a few extra meters was larger than the cost of facing the fundraisers. And we know from laboratory experiments that the magnitude of these costs are quite large. So in the dictator game, people were willing to give up on average 18% of the endowment to avoid playing the dictator game. And this directly brings us to the paradigm that we use in our study. So we also use the dictator game. I assume you all know the game, you see it here. And what we do, or what has been done before, and what we also do is we add an exit option to the game. So this allows the participants to avoid playing the game. If they take this exit option, they get the full endowment that they would get in the dictator game, but the recipient gets nothing. So taking the exit option is actually the same as playing the game and keeping the whole endowment. The only difference is that in this case, so if I take the exit option, the recipient will never learn about the game. So the recipient will not be informed about the game at all. And this is very important for later for the guilt aversion motive. What is the effect of adding this exit option to the game? Since up to 50% of the people end up taking this exit option, the result is a stark increase in egoistic behavior. Why? Because in the normal dictator game, on average, only about 1/3 of the people keep the whole endowment, whereas when the exit option is added, up to 50% take the exit option and the recipient remains empty-handed in more than half of the cases. So what leads to this behavior? There are two motives discussed, guilt aversion and self-image concerns. And as just said, there's evidence for both motives. So what is guilt aversion? A guilt-averse decision maker suffers from guilt to the extent he believes he hurts others relative to what they believe they will get. So the decision maker is motivated by his beliefs about others' beliefs. So these are the second-order beliefs. And there's evidence consistent with this motive. So what they did in this study, they made the game private from the beginning. So even in the dictator game, the recipient was not informed about the game, so there was no guilt from the beginning. So the exit option loses this benefit of the recipient will not be informed, and indeed less people took the exit option in this case. So social and self-image concerns are the desire to be liked and respected by others. So this would be the social image, and by oneself, this is the self-image. How can we achieve this? By signaling traits defined as good based on the communities. So this would be the case for the social image, or one's own norms and values. So this is the self-image. And as we will see in just a minute, the exit option is a very good trade-off between a high payoff and an acceptable image. So let's look at each of these motives in a bit more formal way. You see here the guilt utility model. It assumes that the utility of an action AK depends on the action's payoff and on the guilt that is associated with this action. And so the guilt depends on the second order belief. So what I think the recipient expects me to give. So if I think the recipient expects me to give $5, but I give nothing, I would have a guilt of 5, and this would then be weighted by my guilt sensitivity term alpha. And you instantly see why the exit option is so attractive, because I have a very high payoff, so the same as playing the game and keeping the whole endowment, but no guilt because the recipient will not be informed about the game, and thus there should be no second order beliefs. The self-image model is quite similar. It also assumes that the utility of an action AK is influenced by the payoff of this action, but now also by the personal norm. Why personal norm here? Because we use norm following as a proxy for self-image. And this norm approach has been pioneered by Krupka and Weber. They measured the injunctive norm. So what I think most others believe is the right thing to do, whereas the personal norm is just what I think is the right thing to do. Why do we use personal norms? Because the dictator game is a private setting, and there's evidence suggesting that in such a private setting, personal norms are actually more important, because the enforcement of these norms is done here in the personal norm via the self-image, and injunctive norm would be the social image, but again, in the dictator game, it's private, so there should be no social image. And what Krupka and Weber found is that taking the exit option is actually quite appropriate. So it is more appropriate than playing the game and giving very little. So it has this benefit of quite a good image, or yeah, quite a good image and a very high payoff. So to find out which motive is more important, we can combine the two motives in this utility specification here. And you see these are all attributes of the available choices, and thus we use conditional logic models to fit the data and use mixed logic models to allow heterogeneity in these parameters that we estimate. And again, here is personal norm, but for now on I will talk about self-image. So norm compliance, we use it as a proxy for self-image. So this is the design that we used. We had two conditions between subjects design. We had an informed condition. Here, the recipient of the dictator game will be informed if the dictator game is played. So here, by design, guilt is possible if the dictator game is played. But again, if the exit option is taken, the recipient will not be informed about the game. So here, guilt aversion should be able to explain taking the exit option, but also self-image concerns. And then in the not informed condition, we rule out guilt by design, because even in the dictator game, the recipient will never learn about the game. So in the not informed condition, there should be no guilt. Only self-image concerns can potentially explain taking the exit option in this condition. So the differences between this condition can be attributed to the guilt aversion motive, because guilt should be present here, but not in the not informed condition. So here you see the design we used. We had two measurement time points. They first played the dictator game, then we measured the second order beliefs. It was incentivized. Personal norms not incentivized, because I think there's no way to incentivize personal norms elicitation. Then we had a 7-day break to avoid spillover effects. And in the second measurement time point, they played the dictator game with a BDM exit option. So what does this mean? We elicited the reservation price of taking the exit option. So if the reservation price was higher than the randomly chosen buying price, they had to play the game. If the reservation price was lower than the randomly chosen buying price, they ended up with the exit option. And here you see how we did this. We used the multiple price list. So they only had to indicate their switching point from playing the game to receiving X points. And we enforced consistency, so there was only one switching point. So these are the hypotheses that we have. We expect a lower mean reservation price in the informed condition. Why? Because the lower the reservation price, the more I am willing to pay to avoid the game. And in the informed condition, both guilt aversion and self-image concerns should drive people out of the sharing situation, so should motivate people to take the exit option. Whereas in the not informed condition, there should be no guilt. Thus, we have this hypothesis 1. And then hypothesis 2 and 3 are about why people take the exit option specifically. So the more guilt-averse participants are, the more they should be willing to pay to avoid the dictator game, and same for the self-image. So the more participants care about their self-image, the more they should be willing to pay to avoid the game. So we programmed the study in O3, we run it on Prolific, 281 participants completed both parts, and we pre-screened for US residents to make our data more comparable with the data that I already showed you from Krupka and Weber, who measured injunctive norms. Okay, so here you see the first results. Remember, this was the first measurement time point, so just the normal dictator game. There was no exit option present. And you see that in the not informed condition, so here the recipients were not aware about the game, so there should be no guilt by design. On average, significantly less was given than in the informed condition, where the recipients were informed about the game. So this is our first takeaway. Guilt drives people to give once they are in this sharing situation, and we already know this from the literature, so it's nothing really new. We see this difference is caused by more people in the not informed condition keeping the whole endowment and fewer people going for the 50-50 split. So this is the distribution of the second order beliefs. You see there's no significant difference in the means, and this is actually what we expected, because even in the not informed condition, remember where the recipients were not aware of the game, we still asked the dictators what they would think, what they think an informed recipient would expect them to give. And these are the ratings for the personal norm. Here, the comparison to Krupka and Weber, we see the pattern is quite similar. The 50-50 split is most appropriate, and then it drops off to both sides. The drop off to the left is a bit more pronounced in the data from Krupka and Weber, but in both cases, taking the exit option is more appropriate than playing the game and giving very little. So these are the results from the logit models for the dictator game. Again, no exit option present here. So this was the first measurement time point. This is the informed condition, and this is the not informed condition. And we see here different models. So the guilt model, norms or self-image model, the combination and the interaction. And what you see is that the utility weight of the payoff is the highest utility weight. So people care about their payoff, that's good. They are also guilt averse, so guilt has a negative utility weight, and they care about their self-image. And we also see that there is significant heterogeneity in these parameters. So this is the standard deviation of the parameters here. And we see there is significant heterogeneity in both the guilt and the self-image parameters. So let's now go to the second measurement time point. So this was 7 days later. We see here the distribution of the reservation price, and we see that the mean reservation price is significantly lower in the informed than in the not informed condition. So just as we expected for hypothesis 1. And remember, the difference again is that in the informed condition, there should be guilt, whereas in the not informed condition, there should be no guilt, because even if they end up playing the dictator game, the recipient will not be informed about the game. So the costs in our case of potentially ending up in a sharing situation are quite large. So more than a third of the endowment were they willing to give up in the informed condition, and 22% of the endowment in the not informed condition. This led to the following distribution of exit options and games played. And as already said, the hypothesis 1 is confirmed. So this, again, guilt apparently drives people out of sharing situations. Again, we already knew that. As we'll see later, we will see which motive, guilt aversion or self-image concerns, is now actually more important. Here you see the distribution of the actions of the dictator game with the exit option. So we see that conditional on playing the game. So if the exit option was not selected for these participants here, the correlation between the game they played 7 days before and this game is very high, so 0.77. And we see the same pattern, so less is given in the not informed condition than in the informed condition. And we again see the same pattern here with people who keep the whole endowment and people who take the 50-50 split. Okay, so now the mixed logit models for the dictator game with an exit option. We see that the payoff again is important, but now avoiding guilt is even more important. So it has a higher utility weight than the payoff. And interestingly, now people no longer care about their self-image. So as soon as the exit option is available, people no longer care about their self-image. self-image only enters the utility specification significantly via the interaction with the guild term. So these models here tell us about the importance of these motives for the whole game, but we are specifically interested in why people took the exit option. And what we can do in this mixed logic models is we can let these random parameters be informed by the reservation price. So remember, the lower the reservation price, the higher the probability that the exit option is implemented. We see that this increases the utility weight of guild even more, and consistent with our hypothesis, guild and reservation price, so this is like an interaction, you can see this as an interaction, are positively correlated, or there's a positive interaction. So the more guild averse someone is, so the lower the utility weight, the more negative the utility weight of guild, the lower tends to be the reservation price. So the more this person wants to avoid the dictator game. Again, self-image has no influence or even tends to be negative. And the correlation between, or the interaction between self-image and reservation price is positive. So this is contrary to what we expected. So this means that the more people care about their self-image, the higher their reservation price, thus the more likely they are to play the game, not to avoid the game. We also run the robustness test. What we did here is we took the data from the dictator game, and we still have this interaction with the reservation price. So remember, the game was 7 days before we elicited the reservation price, and we still find this result that the more guilt-averse participants were 7 days before we elicited the reservation price, the lower the reservation price. So the more they want to avoid the dictator game. And we do not find this for the self-image again. So now the question is, why do people not care about their self-image as soon as the exit option is added? Because you see here again, for the data of the dictator game without an exit option, they care about their self-image, but when the exit option is added, they no longer care about their self-image. So what we did here is we used the second dictator game where the exit option was available, but we only used the observations where the game was played. And as you see, as soon as we do this, so when we exclude participants who took the exit option, now the self-image enters the utility specification again significantly. So this suggests that people who take the exit option actually do not care about their self-image. So they're not concerned about their self-image. So to sum up the results so far, we have a lower mean reservation price in the informed condition. The more guilt-averse participants are, the more they are willing to pay to avoid the dictator game. So this is consistent with the guilt aversion motive. And we do not find this for the self-image motive. On contrary, the more participants care about their self-image, the more they are willing, also the more they want to play the game. So what is the conclusion of the study? We saw at the beginning and also in our study that most people dislike being in a sharing situation like the dictator game, and we wanted to find why this is the case. And our evidence suggests that people do this to avoid guilt and not to preserve their self-image. So on the contrary, people who take the exit option seem not to care about their self-image, or not so much as people who end up playing the game. Thank you very much for listening.